So hello everyone. Now we will start with a linear data structure array first, and what we will understand when to use array, what are the different scenarios where we can implement the array in a best suited data structure, and where not to use array. Okay, what are the different scenarios where we should not use arrays? So you'll get a clear idea about it. Then next in this session, we will go ahead with the list. So let's start. So obviously everyone aware about the array. It's a sequential linear data structure and with the consecutive memory allocation. And array is a block of one continuous memory that starts from the index 0 and with the specific size given. Okay, whenever you are declaring array, you have to provide with the size there. So what will be the length of your array, and that particular memory will get adjacent memory. It require adjacent memory. That is also one more thing we will discuss. So it requires the sequential memory allocation, and as per the size, as per the length of the array, it will allocate the thing. So that way it mentioned that it's a sequential and linear data structure. So here you can see that there is a array of integer, and the indexing are mentioned over there. If we are declaring one array A having the length 5, and obviously the indexing will start from 0 till 4 to allocate the 5 uh, integers, and the memory allocated continuously. So if you want to write something, you have to mention the index position where you are writing and then allocate the, like here in A of 2, we are allocating 33. So it's a very common and basic data structure. I hope that everyone aware about it and they have tried some examples in array also. So if no, then these are some examples. You can try and error. Uh, Here you can see that the how C hash or C sharp declares array. Okay, there are different types of arrays, integer, string, and how there are the different ways you can declare and initialize. So this is also called as a static data structure, because we have to mention the size compulsory. Either mention the length of the array, otherwise you can directly, on one more option is you can directly allocate the values. Okay, so as per the value assigned, that will considered as the length of the array. So you can say is about some, these are some examples. Okay, and because it is some fixed size and it will not grow automatically. So when the list is full, now question is like how we are adding few more details, few more data in it. So the second, we know this is the second concept about the data structure, which is implementation. So in other words, you can say that you have to do some concrete implementation of this static list. So which you can store the elements, read the elements, modify the elements. So these static data structures is implemented by the array with a fixed size, and after creating it, uh, here it is, you can declare the dynamic size also. In the example number 4, you can see that. So now what are the different scenarios where array data structure is best suited? So arrays are fundamental data structures, and it is used in a various application to store and manipulate the collection of data. Below are some common applications of array. Now, there are some disadvantages and advantages of every data structure. So based on the requirement, you can utilize these data structures in your application. Now you are storing the list of a data, then array is the best data structure for it. If you are sorting and searching in this scenario, arrays and grids, input and output handling, managing the collections, graphics and game development. So Sorting list is like arrays are often used to store the collections of a data such as the numbers, strings, and objects. For example, you can use the array to store a list of integers that represent the test scores. So this is very good, simple, sweet, and not complicated one. Again, next is the sorting and searching. Arrays can be used for sorting and searching. Why? You can sort an array of element in ascending or descending order using the algorithm like bubble sorts are there, quick sort is there. The search algorithm, such as a binary search, can be applied to find specific elements in a sorted order and implementing data structures. Uh, so again, more complex data structures such as a list, stack, queues, and hash tables. Many data structures relies on an array to store and manage their elements. So basically, they are advanced data structures, but internally they are using array for these things. Again, arrays and grids, like two-dimensional arrays are available, multi-dimensional arrays are available. So they are useful in a graphics programming mostly for the game development and scientific simulations. Now, arrays are again used for the input and output handling. It is used to buffer the data, okay, which is read from the written files, databases, or network sockets. So this allows efficient processing of a data in a blocks. So block wise, it get sent into the array, and then you can manage the things. Again, managing collection arrays can be used to store the collection of objects or a data structures. So, for example, you can use arrays to implement a simple database or a contact list. If your product and project is not that much complicated, rather than implementing different complex data structure, it is always better to use a simple thing. And now graphics and the game development, obviously, we mentioned before also that it is really beneficial in a graphics because arrays are essential for storing and manipulating pixel data. So these pixel data is nothing but an important aspect of every graphics and game development or a designer. So managing game state, creating levels and maps. So these are just few examples where you can or how you will use the array in a program. So arrays are versatile and serves as basic for many data storage structures and manipulate the task in a various software applications. So I hope that this data structure is clear to you. Now, what are the advantage? Efficient random access. Obviously, it provides the constant time O of 1 to access a particular element. Because for the accessing of the element in the array, you should know there are the indexing available, right? So you can directly access an element by knowing its position in an array. So the access is very fast. Okay. Now predictable performance. So everything is fixed on the basis of an indexer. So access element in the array has a consistent and predictable performance characteristics. So fetching, searching is really fast, okay, which makes it suitable for many applications. So it's obviously a simple syntax and fixed size. Now, fixed size can be the advantage as well as the disadvantage. In some cases, having the fixed size of array can be advantageous because it enforces the limit. Consider you want to create only 10 people or user in for your application. So obviously, rather than creating any using any other data structures, go ahead with the arrays because it's provide 10 only. 10 users are only available. Like this, if you want the fixed size kind of a data structure, so obviously it is very useful, which can help prevent memory issues, improve predictability. So always it is beneficial in such scenarios. Now, what are the disadvantages? Obviously, fixed size. Fixed size, it means arrays can also be disadvantageous when the number of elements are unknown or can be changed over the time. So resizing array can be inefficient and many requires creating a new and larger array and copying the elements. Now wasted money. Why it is so? Array allocate the memory for the maximum number of elements they can hold, even if the actual number of elements are small. So for example, you created the array of a 10, but only the value are available in the 3 memory allocations. Still, it's acquired that particular 10 memory location. So obviously, it's a wasted of a memory. Now, inefficient insertions and deletions, obviously, it's having the indexing. So if you are, consider the worst case scenario, if you want to delete the element which is available at the center position. So consider you have an array of a 10 and you want to delete the element which is available at the index 4. Now, what you need to do, you can delete, but all remaining elements or data you have to move forward. So, lots of moving and shiftings are we have to do in deletion and insertion. Same for the insertion. If you want to insert the data at the particular specific location, you have to just shift the data here and there, and then make that particular space available. Then you can insert. These are the some uh, ways where you can see that this is inefficient. Lack of built-in functions. So that there are built-in functions when you are using collection. I know that all of you are using collections. So obviously there are some built-in functions. We directly call them, we pass them as an argument, and then everything handled by that particular class. That is not available. There are rare built-in functions are available. So homogeneous elements and inflexible data structure. So these are homogeneous elements are nothing but arrays typically store the elements of the same data type. And if you need to store the elements of different types, obviously you have to create a one more array, and again, again your algorithm will get little bit complex. And again, you can't perform that particular required operation. So inflexible data arrays are not always the best choice for the complex data structure. So the when you will prefer array, you have some restrictions. The amount of users are very less, data is also less, and you want the fetching or visiting the particular data very fastly. Searching operations and fetching operations you want fast then at that time, but it should have the data length of the data should be small. Okay, if you have a very complex structured data and very large data, then obviously it is not beneficial. It is beneficial when you have a small data and uh, where you want to do the faster searching and fetching thing, then obviously it is advantageous. Now let's go ahead with the list. So obviously list is a common real world entity and the collection of objects of a same data type. Again, it's the extended version of array. Okay. So let's take an example. We want to make the list that can be performed following operations. Store a given number of elements of any given data type. Read the elements by their position, write, modify, and any position in the list. There are two types of list, static and dynamic, arrays and linked list. So here we are dealing with the list, which is an abstract data structure. And this is the some complexity, accessing the elements from the specific position and all. So static and dynamic list, sorry, static dynamic list, we are already aware about the static list example array. Now let's go ahead with the dynamic list in ASP.NET. So this is the analysis. If you want to observe, you can just open the slide and just read this. So we can access any element in a constant time. So it is a good thing. Insertion, deletion of the elements are little bit costly. Addition of the element when array is full is again time costly because we need to create some space and allocate and then. So there is a problem with the space complexity. We also have one problem here about the array implementation. It makes our memory useless. So when we want to insert the element in the array, we encounter the filled array and then we create a new array of a double size of the previous array and same thing as we discussed. So best implementation, as we analyze this array implementation, we see that it is costly in terms of both memory and space and time. Both the complexities are a little bit higher when you are taking care of a particular scenario. So we need a data structure that implements the our previous abstract data structure efficiently. So list is abstract data structure. Who will perform this dynamic behavior? So that grows its size automatically when the list is full. So we can say is that a linked list. So linked list you can create in ASP.NET by means of this particular class, and this T is obviously you are aware about, it's a generic, and you can pass the data structure of which type of a list you want to create. So it's a represent a strongly typed list of objects that can be accessed by means of an index and provide search, sort, and manipulation list methods are built in available. So linked list data structure implemented in .NET framework as a generic data structure in the system.collection.generic namespace. The principle of functioning of a linked list structure is that each node in the list has a reference to the next node except the tail of the list, which has no reference. This is the tail. So as you can see, initially we are adding one element here before 3. The node is 2. Previously head represents 3 at 3. And now the another element we inserted, now that particular element mentioned as a head because we are inserting at the first location. So let's go ahead. So the list class is generic and which is equivalent of ArrayList class, and it implements iList generic interface by using an array whose size is dynamically increased as required. So here it is. We can add the elements, node, or data very quickly in the list. An example of search in the linked list of the third atom starting from the end. So here it is. You can see the length of the linked list is 5. Element position is nothing but a fifth. So you have to search from first to last. You have to fetch the data, and then it's searching, and then it's finding it. Now let's go ahead with the example of search in a linked list of the third element starting from the end. So just allow me a minute. So let's visit this example which is available. So let me exit. Okay. So this is the ASP.NET Docs, and here it is. Wow. So this linked list is available in the namespace system collection generic and represents a doubly linked list. Okay, doubly linked list. I hope that you are aware about it. So you can visit forward as well as back. Okay. So in a singly linked list, one previous node is linked with the another next node. But in a doubly linked list, next node also can we can make a link to the previous node. So we can travel from first to last and last to first. So it is traversing is little bit fast in a doubly linked list. So type of parameters is a T, specifies the element of the linked list, object, linked list, implementations are I collection, enumerable, read only, I collection, enumerable, ID serialization, callback, and serialize. Now this is a better example, okay? So demonstrate many features of a linked list. So first of all, we need to create a linked list. So for that, how we will create it? You just have to use the class linked list. You have to mention what type of a linked list it is, and you have to pass kind of a data. So for the example, we are passing this array words to the linked list. Now we are displaying the linked list, and add first. Now this is the scenario where we want to insert the element or a node at the first position. So this is the built-in method available, add first, and we are adding that particular data at the first location. Move the first node to be the last. Now again, how we will do it? Built-in methods are there, don't worry. So you can do it. Mostly, normal list is used for the better searching purpose, and linked list are using whenever you are frequently doing insertion and deletion or movement or just shifting the data here and there. So here it is. So this is the best case scenarios where you can use the linked list, okay, over the list, okay, over the array, over the list. So whenever you are doing lots of insertions in your data structure, then obviously the linked list is a better solution. I hope that you will use these data structures when you are developing the applications. I have observed mostly in any kind of application, everyone is only, whenever we want to store the data, we are storing in the list. We create them kind of object of a list. We are adding that data into the list. We are not there. We are not taking care of the, we don't remember that we have a different data structures also, and we can use them and all. So here it is. So if you want to add the node to the last, you can perform these things. Okay. So here it is. There are some scenarios, worst case scenarios, last node, first node, what we need to do, indicate, and we need to add a particular node after the thing. So there is a add after method is there, remove first method is there, remove last method is there, add first method is there. So as per your requirement, you use these methods. Again, if you want to find something, there is a find method. Okay, by means of a value, you can find. Again, add before, indicate the node. Again, there are some operations here we are doing, throw the exception when you are adding the node. Wait, let me scroll down. So these are some scenarios or examples available on the this documentation, ASP.NET documentation. We are using latest .NET 8 version. So just follow this particular link where it is. It is available in the slide. So you can go ahead and just follow this link. It will get open directly. You can just try that particular example, understand, okay, efficiency of a list. Now, what is the final remark? Okay, each node in the linked list object is nothing but a type of a linked list node. So because linked list is made up of a list, is made up of a node, so every node implementing this particular class linked list node. Now it's a doubly linked list. Each node points forward to the next node and backward to the previous node. So list can contain reference types, perform better when the node and its values are created at the same time. So if you are creating the node and assigning the values, then linked list accepts all null as a valid value property for the references. It stores the node, so object of the node. If you do not have any values at that time, then it's by default it's signed or accept the null. If linked list is empty, the first and last properties contains null. Linked list class does not support chaining, splitting, cycles, or other features that can leave the list in a inconsistent state. Okay, it means it's uh, uh, we can say it as a kind of a deadlock or a continuous loop kind of a things. So list remains consistent on a single thread. The only multi-threaded scenario supported by the linked list is a multi-threaded read operation. So it doesn't allow the multi-threading, and it only allows you to read in a multi-threading operations. Now let's go ahead. Now scenarios when to use the linked list and when not to use the linked list. So in a dynamic, if you want the dynamic size, when you need the data structure that grows or shrink dynamically. So example, implementing the dynamic queue or stack. So you can add the elements from one end and remove from another without worrying the sizing of an array, right? So this is the one scenario where you can use the linked list. If you are having the frequent insertions and deletions in your data structure. So when your application involves frequent insertion deletions of an element, especially at the beginning or a middle of the list. So in a music player, playlist where song can be added or removed anywhere in the playlist. Okay, when you are creating a playlist, then at that time you shuffle it. You want the particular song should be on a particular location, or you're adding it, removing it. So linked list allows this efficient insertions and deletions very frequently. Now, one more is a memory efficiency when memory overhead due to the unused capacity in arrays, like arrays that only partially filled is a kind of a concern, right? We have discussed that allocation for the 10 spaces, but only 5 or 3 spaces are filled, then that is the vestige of the memory. So in that case also you can use the linked list, implementing a spare matrix where most elements are zero and non-zero elements are stored using the linked list. Yeah, this is also one more scenario. Non-continuous memory allocation. So when you don't need and don't have a continuous block of a memory available, then at that time, obviously, the linked list is beneficial. In what is the best example of it is nothing but a hash table. So implementing hash table with chaining to handle the collisions, each bucket of the hash table is linked with the list that stores all the elements hashing to the same index. So internally it's using the linked list. Now undo functionality when implementing the features that requires the undo operation. So in a text editor, a linked list can be used to maintain the history of actions. Okay, we are maintaining the versioning, right? So each node is an action, and so that you can easily traverse back by means of undo operations. Now, implementing the graphs when representing a graph, particularly the adjacency list where each vertex edge need to be stored. So when you are creating a particular graph, so it get created at the particular vertex, then obviously linked list is advantageous in that scenario. Sorry. Representing a social network where each person is considered as a vertex and the connection or edges. Each person can be a node and their connection can be linked via using the list. So there are various scenarios where you can use the linked list. Do use the different data structure rather than using only list. Now let's go ahead when not to use the list. So if you have a random access, so obviously we understood, we aware about that, we discussed the array and list. So when you have a fetching and searching quick operations, then at that time, those data structures are very beneficial. But same case when you are using the linked list is little bit slower. A random access, if you need to frequently access the element by means of an index, linked list obviously it's sufficient as they require the traversing from head to desired index, or you just check the data, then matching and then fetching will happen. Now, high memory overhead. Now, in a linked list, each node is nothing but requires some extra memory to store data, to store the link to the previous node or link to the next node. So obviously it's extra overhead. So because it's storing the kind of a pointers or references to the another nodes. So if the memory is the constraint, you have a frequent access operations as an array might be better. Linked lists are most useful when you are needing the flexibility in the memory allocation and when the operations you need to perform aligned with the linked list strength in insertions, deletions, and memory efficiency. So these are the ways, these are the different scenarios where you can use array, list and linked list as per your requirement. In next video, we will understand the stack, queues, then there are different collections and so on. So here we stop for today. Take care.